Okay, so this is a second example that we're going to use for vectors. And this is going to be a little bit different because we won't have street blocks to work with. It's going to be a little more random motion, or random path. Not random. We're going to follow a path. And I drew like what you might see on a map here, a little hill. And here's a trail that we follow up here. And this is something you do if you're backpacking or hiking and you want to find a distance. Obviously, the distance that you walk along the trail is not going to be the same as from the distance that you started. But if we want to do that, I'm going to imagine that we take a GPS reading at some point here. You know, maybe that's where we camp. And I'll just put that right there. And then we have one at the peak, and we're going to assume that we start at the origin right there. Okay, so if we want to figure out how far we went on the first day, our vector is going to go from the origin to there. And that's going to, we'll figure it out the same way as we went before. We'll have a GPS coordinate, and we'll just subtract. So we'll go a certain distance east, and that'll be our longitude. We'll go a certain distance north, and that'll be our latitude. And it'll be we could calculate it the same way. Now the curvature of the Earth affects that a little bit, and also altitude. But we're just going in flat two dimensions right now. And then you would do the same thing for your second day. Go over here, it'd be a certain distance north, and so it would be like that. And I'll draw these components in a different color. I can actually draw them in blue. And so for the second day, our total distance is going to be the same. And we'll measure that just like we would do with city blocks or some distance along there. So we go a certain amount north, and then we go back west. And so this is an example for any path that we're going to do. And so the next step is to figure out how to add these. I'm going to go ahead and save this. I'm going to clear this off, and I'm going to draw coordinate system. Another coordinate system, nice and clean. It's going to be Y and X. Okay, so like we did in the last one, it's basically going to be the same. We're going to go a certain direction in X and Y. We're going to call this vector A. Make it bold. And so oftentimes vectors are bold, and then they also have arrows over the top, which that's kind of a big arrow. But oh well, we'll use that. And then we're going to have a second vector, which is going to go here. And that was just like our last two problems. And that'll be a vector B there. And that's just how we label these. Okay. And so then to find the distance we traveled between A and B combined is going to be the vector C. Okay, so to figure out how far we go from the origin to A, and then go from A to B, it's just going to be C. So we have to add those together. It'd be like going one distance and then going a second distance in one dimension to figure the total distance you would add together. The basically works the same in 2 dimensions, except for we are counting for 2 dimensions instead of 1. So this will be A plus B equals C. And it's just like that. That simple pretty much, and we'll get into the math of the components here in a little bit. But you can usually just do these bold, or you put the arrow over them, and I'll put the arrow over them so we don't get confused. Okay, so some of the properties of these vectors are, so A plus B equals C, and we'll see, I'll show you here that we could do it the other way around. So there's C, and so I can take this vector B and put it at the origin there. And I can take this vector A, put it tip to tail, and that's how you always measure it. Point to tip, and then so it's tail to tip. So then it's A there. And that's C there. And if we look at it, that's the same as going from the origin to B and B to A. So that's the same as B plus A is going to equal C. Okay, and then since they both equal C, then we know what A plus B is the same as B plus A. And I know it gets tiring putting the arrows over these, but they're all vectors, and it's important to use our notation right. So that's a commutative property, and that's an important property of vectors. One other property that we have is we can take a vector like B, and I'll draw B again. You can imagine it's still on the same plane and coordinate axis. So there's B, and if we draw a vector like that, it's going to take us back to the same spot. And we're going to call that negative B. This is negative B. And this is B. And obviously we can do that for A too. Vector arrows. Okay. And which is probably clear to you, I'll just say that B plus a negative B is going to equal 0. And so that means that A minus B is the same as A plus minus B. And so that's our null vector. That's another important property of vectors. So that's good for the visual representation and the vector properties of it. And I'll get more into the angles and the math part of this lecture. So that's good for now. Thanks.